Okay. Do you all see Chuck the Pug?
Yeah.
Yes.
Okay, great.
Awesome.
This is the most important news in the carbon world. As of late, somebody has taken to taking photos of Stacy Smedley's dog and putting carbon memes over the top of them. So, for your entertainment, this is how I feel on a weekly basis. What if we never figure out the right way to account for biogenic carbon emissions at the end of life? Fortunately, Jacob and friends will get into that a little bit with their tool. But right now, what I'm wanting to do is zoom out a bit. Bree referenced a mass timber guidebook that is a project that I've been working on with our firm Perkins Will. I'm an architectural designer, but we also have a lot of research initiatives at our firm, and one of them is a building technology lab and another is a material performance lab. And within the building technology lab, we've been asking, what does it mean to use mass timber, and think about it both as a piece of craft and as a living material. And zooming out a bit, I'm wanting to talk about the carbon cycle. That is because I feel like design teams as a whole, we can be better educated about the sources and the impacts of our materials. And then we can also advocate for carbon reduction through supply chain. And to do that, we can start with strengthening our understanding, and that's part of why we're all here today. And then learning more about systems and analysis tools and how to ask the right questions so that we can collectively make a powerful, positive impact. Starting with the carbon cycle, this is a very cartoon version. Kudos to the Noun Project of the carbon cycle. And what we're looking at here is that there's both inventory and there's impact, and thinking about where carbon lives, where is it? That's just kind of an inventory. Is it in the atmosphere? Is it in the water? Is it in the soil? In some cases, carbon flows very quickly, such as between air and water. It's almost a continual exchange. And then there's a slightly slower carbon cycle. Say we chop down a tree to make paper, but then the paper might end up being incinerated, or there are impacts from recycling it that go up into the atmosphere. That is a fast carbon cycle as well. And then we have the very slow carbon cycle, which when we introduce anthropogenic emissions, we kind of break that. So the very slow carbon cycle is the lithosphere and Earth's crust, the deeper levels of soil, and fossil carbon. And what's happening right now is that anthropogenic activity, our activities, is bringing fossil carbon out of the ground and throwing it back up into the atmosphere more quickly than this cycle can handle. And within that cycle, that's where the biosphere and forests live. So forests sequester and store carbon, and they cycle it from the atmosphere, bringing it back down into the biosphere. And then there are processes that may send it back up or may store it over time. But what we need to hold on to here is that in order to combat anthropogenic emissions that are faster than they would usually be, we need to store that carbon for a while. So for example, timber in a building over the course of 100 years is much more impactful than making paper. However, if we just put timber in a building and then tear it down and replace that building, what happens at the end of the life of that timber will indicate whether we're really helping or if we're just exchanging at the fast rate that we have been. So here's an image of the natural forest carbon cycle, and left to its own devices, the forest will pull carbon from the atmosphere. It will uptake that carbon and it will store it either in the mass of the trees. Timber is about 50% carbon by mass, and the rest of it is water at harvest. And then some of that ends up below ground. If we look at forest carbon stocks, more than half, well, more than half, it's like 75% practically, of the carbon from the forest is being taken below the ground. So there's live roots, dead wood, litter, organic soil, and then mineral soil comprises 43%, 44 almost, of the forest's carbon. A big issue here is that when land use change occurs and there's something like, say we clear a forest to grow palm oil or to raise cattle, for beef, then tilling occurs, and that soil carbon can get stirred back up into the atmosphere. The impact of land use change is far greater than just, are we cutting down trees and stopping them from doing their work? It's a larger disturbance. But left to its own, the natural forest carbon cycle, we would have disturbances that are occasional, like decay or fire, and then we would have resilience, where the new trees are growing. And the text here says that the natural cycle is a closed loop, diverse, evolving, growing, decaying, and perpetually providing our planet with life. A human's relationship to this ecosystem is at least as old as humanity. And over time, we've come to understand the forest as a source of protection, heat, nourishment, identity, inspiration, product, and profit, more recently, alike. And this is where things start to get tricky, is that we're looking at a living thing that has its own economy. Perhaps the carbon economy could play in nicely with that. And we're taking it and we're bringing it into our dollar economy, or our capitalist economy, where in that economy, a tree is worth more dead than it is alive. So what do we do about that? And that's where I think it's important to look at supply chain. And supply chain is the system by which trees become mass timber. The system could be understood in terms of inputs and outputs or products, but timber is more than a product. It's the only primary structural material that has been approved for use in buildings that is derived from a living and carbon sequestering resource. So this is where we introduce the managed forest carbon cycle. And the life cycle stages are in this diagram. We have the product stage, where the raw material is transported and manufactured through the mill. That happens within what is called a bread basket by some. And usually the radius of forest to mill is about 50 miles, I believe. It's not very far, because timber is very heavy when it is harvested. It's near 50% water, and it's round, so it's not easy to transport. We need mill infrastructure close to forests in order to have a sustainable forest to product loop. And then we have the construction process stage, and timber is fabulous for many reasons that I think we're aware of, and we've heard that we can save carbon in construction through efficiency. And then the use stage, and this is key, as is end of life and reuse, because this effectively becomes another carbon pool. We have the first set of carbon pools where trees are creating biomass below ground and soil, and they're also drawing down carbon into their own mass. But then when the timber is harvested, it's holding carbon. And as that pool continues to grow, if we are also planting new trees and following best management practices, there can be a positive feedback loop. And I like to say that, and this is a thing from permaculture and regenerative design, humans are disturbers, we're disruptors. We're also consumers. We have a role to play in doing that, and we can do it in a way that's symbiotic with ecology if we do it, if we're informed. This last bit over here is, I know the text is small, this is from our guide, but the disturbances like wildfire and blight and other land use change can break this whole cycle. And so if this cycle, the timber product life cycle, somehow breaks the managed forest cycle, then we have a problem. Like if a forest is cleared for a shopping mall or transitioned away from wood production and into something else, then that can be an issue. Or also just if it's not maintained and it's susceptible to wildfire, and say there was like a monoculture planting, and then we have beetle blight and other things. And that's where certifications become really important in best management practices, because we can also mitigate some of these disturbances and ensure ongoing use of forest as forest. This diagram is a little bit hairy, I think, to get into here, but the idea is that we have supply chain, and then we also have our specs. And if you were to just blur your eyes for a moment and think of this as kind of like a wonky tree, there are all of these inputs going into our buildings. And then for each material that we specify, there are a ton of different impacts that those materials are related to. So zooming in, if we have concrete, steel, aluminum, glazing, insulation, wood, they're all related. And anytime we specify any of these, we have something to say about the impacts associated with that product. Super cool thing is that wood is the only one that has a tiny green arrow here. The green arrow is representing carbon that's being sequestered. The red arrows are signifying emissions, carbon dioxide equivalent. And there's a huge opportunity with that small green arrow for wood, not only to do its own work, sequestering, but also to do the greater work of being a part of a healthy forest management system. And then layered into that, there's the value of substitution, which is simply that if I'm not using as much cement to go into my concrete because I've specified timber, then there's both a reduction on the one side, a smaller number, and there's the opportunity for regeneration. And this is a lot to take in, I think, for an average team. I think we want to focus on the warmth and the positivity of wood and why we love it and the living benefit of the forest. And the beauty of this to me is that all of this information is summarized in an environmental product declaration. If I were to go back to the other slide, there is an EPD summarizes the carbon impacts of any material. And if we can have EPDs for timber, or if those are lacking, if we can specify certified timber, then that does a lot of work to understand supply chain or to help us to reduce the potential impact of the supply chain. There's another Chuck the Pug. Chuck is grumpy because we haven't set a science-based target. And again, I think that is where environmental product declarations and certification systems come in. Others are going to touch on this more later in the presentation, but according to the ISO that governs life cycle assessment, we can count timber as a carbon neutral choice if one, either it comes from certified forests or mills, and there's a list of certifications here. They all have some pros and cons, but they're getting at the same thing, which is better management practices, and that can impact watershed health and habitat. It also tends to impact carbon storage. And then 2, stable or increasing forest stocks based on reporting. If we look at North America, typically right now with current regulations, as long as those regulations stay in place, our stocks are stable or sometimes increasing. As demand increases, the risk is that if demand goes up for unsustainable wood, that timber could come from parts of the world that are clear cutting more. It could be illegally harvested, or it could even come at the cost of removing some of our own forest stocks without replacing them. So it's very important to get certified timber if we can. This is the last slide that I have to share. I'm just wanting to make a distinction within reducing carbon in timber, that we can reduce it by minimizing emissions. And through the production of timber, there are going to be fossil emissions that occur. And through the disposal of timber, there are biogenic emissions at end of life. And then we can also reduce it by just avoiding carbon, right-sizing a building, optimizing massing, choosing the lower carbon equivalent products, and also power sources, and then reusing, adapting, and designing for circularity. So that's avoiding. And then there's the sequestration work that the timber is doing. And a project could reduce their carbon through sequestration, through offsets, through actually planting trees on site or planting like wetlands instead of grass. And then through certified carbon storing materials, and here the certified mass timber is that. And then there's time, which goes back to the carbon cycle slides, where we're saying that if something is stored for a long time, then it is kept from going back into the atmosphere, and we can hope that we're doing a net positive service. And different systems measure this in different ways. Right now, Tally kind of puts this all in one number, and at different life cycle phases, Tally, the LCA analysis tool, will say we are either drawing down or emitting carbon, and it puts them together. The EC3 tool is currently just only looking at this from A1 to A3, and it's not considering sequestered carbon, but you can find that info in EPDs, and that tool will evolve over time to include sequestration. But others are going to talk more about what do we do about this and how do we measure it. Thank you.